So let's take a look at today's lesson. We actually have two different concepts that we're going to be looking at today. One is evaluating sine and cosine functions, and this will be using our calculators. So the first part is with the calculator. Then the second part of our lesson, we're going to look at writing equations from graphs. So those are the two topics that we're going to cover today. So let's first of all just keep in mind that when we're using our calculator, we do not round into the very last step. And really for anything, not just this, but any kind of work that we're doing on our calculators, we need to be sure that we don't round to the very last step, because if you round in between, then your final answer is going to be off, and you'll lose points. So we just want to keep that in mind. We don't want to round until we're done. All right, so we have a couple of parts up here. Here's our equation, 2 plus 5 cosine pi over 10 x minus 3. So if you would, let's get our calculators out and let's enter this. We're going to enter this in y1. So we'll pull the calculator up. We'll go to y1. Okay. All right, so it's 2 plus 5 cosine. And then I'm going to do a fraction, alpha y equal enter for pi over 10. So pi over 10. Open up another parenthesis. Then we have x minus 3. Close that parenthesis, close that one. Okay, so this is what you should have in your calculator, 2 plus 5 cosine pi over 10 times x minus 3. Now this is in radians. I think we can all tell this is in radians. We need to be sure that our calculator mode is in radians. So I would recommend you just double check it first before we proceed. Make sure that you're in radians, because in the units, we've been switching back and forth, right? So it just doesn't hurt to double check. So we are in radians, so this is good. All right, so the first question, it wants to know f of 7.8. Well, what does that mean? That means 7.8 is an x value, and they want us to enter the x value. So several ways to do this. I'm going to do it by going to second calc value. That's what I'm going to do. And yes, it's gonna graph it. I have a little bit of a different window going on, but it's gonna graph. And so see how it pops up down here at the bottom, x equals, so we're going to type in our 7.8 and hit enter. And so here is our y value right here. There's our y value at 7.8. So we would answer that question, we'd say equals, what, 2.314. 2.314 or 3139. Is everybody okay with finding that value? That's pretty straightforward. Sure. You could do table ask. I mean, there's several ways to do all the things that I'm showing you. I'm just trying to vary it so that we have a different, to see things in a different way. So let's close this out for a second. So here, this we're going to say that equals, what was it, 2.3139? Now I actually missed writing a section on here. There actually should be A, B, and C. So I'm going to write it in. If you will help me out. This actually is part C. So part B, let's just add down here. We want to find the general solution. Find the general solution where f of x equals 6. Okay, so this C is like a part after this one. We find the general solution, then we find the three positive values. So this vocabulary word, general solution, I'm hoping that really rings a bell. We understand what that means, right? We've been traditionally putting like plus 2 pi n, or plus 360 n, or plus pi n, depending on where we are, right? So that's a general solution. So we're actually going to find a solution for when y is 6. Let's see, what in the world does that mean? That means we want to set our equation equal to 6. 6 equals 5 cosine pi over 10 x minus 3. I mean, that's what it's asking us to do. We really are not going to have to do that by hand, right? We have a calculator, but that's what it's asking us to do. So when we do this, let's go back to our calculator. Is everybody okay with this? I'm actually going to have to erase it. We have what we need. So basically we would say 6 equals that. So let's go back to the calculator and do some work. Okay, so to do that, I would go to my y equals, and I would go down here and put a 6, right? So we're basically going to intersect our trig equation with our y value. The y value is 6. So we graph that, and we see, because I have my x-axis, you know, I have quite a few more x's showing, we see multiple solutions. All right, so what we want is we want this location, right, and this location. We want to find those two locations. So I'm going to do second calc. We're going to do intersect number 5. So one thing that we may or may not be aware of that I want to point out is that right now my cursor is on the trig function, and that takes a long time to scroll on that, doesn't it? We can actually change the function that we're on by moving the toggling up. So we just, this up and down arrow. So notice I toggled up, and now you can see I'm on that function. If I keep toggling, I'll be on the other function. You can switch back and forth between equations, and actually I move faster when I'm on the line, so I usually just toggle to the line, and then we'll just go over to our first intersection. Okay, and then we'll go enter, enter, and enter. We'll let the calculator do its thing. So the calculator is telling us our first intersection is 0.9516. I'm going to go ahead and write this for us up here. So x equals 0.95. We'll go ahead and round to 2, 0.952. Okay, so that's one intersection. Let's get our second one. So we're always looking for at least 2, right? That's what we've learned on general solutions. We need at least 2. So let's do this again. So second calc intersect, and now we're going to go, I'm going to go use the line, move over here to that one, and then do enter, enter, and then enter. And so my second one is x equals 5.048. Now we have the, I guess, task of figuring out, well, do I need these, or are these included in my solution? So let's calculate the period. We really need to calculate the period of this particular equation to determine what's going on. So if you recall, this is cosine. So period is equal to 2 pi over b, right? That's our little formula for cosine and sine when we're in radians. So our b is pi over 10, so the period is going to be 2 pi over 10. So we fix our complex fraction, and we get 20. So the period for this function that we're working on is 20. We all okay with that? So just to double check, I'm going to find this intersection and just see if it's 20 spaces away from this one. If it is, we know we have everything and we can stop. All right, so let's do that. So let's find that other intersection just for fun. I think we're fine, but let's just find it. Uh-huh.
So in this, like, type of graph, you should always have your x-axis, like,
Good question. So originally I had my window open at 10, and I couldn't see the other one, and I wanted to see the other one, so I just went and changed my window to, since our period is 20, I changed my window to like 30 so that I would be sure to get at least 2 cycles in. So I'm just double checking again. I think we all know what the answer is going to be, but why don't we just double check just for fun, right? So second calc, we're going to do the intersection, and I'm going to scroll right over there to the other intersection. And so let's see what happens right here. So we'll do enter, enter, and enter. Okay, so our intersection is 20.9516. I think we can see that is 20, right? That's, if I added 20 to this one, I would get that. So this is going to be in our general solution. We have the solutions that we need. All right, so let's go to our other page. Let's write down our solutions. All right. So we have our x equals 0.952 plus, it's going to be plus 20n, isn't it? It's going to be plus 20n, not our normal. We need to be aware, right? Be careful. Lots of mistakes happen here. We just kind of assume that it's a normal period, and it's not. And the other one is, what was that? It was 5.048 plus 20n. So here are our general solutions for this particular situation. Now they want us to write the first three positive values where, you know, this is true, where y is 6. So we say x equals 0.952, 5.048, and we know the next one, we saw it already, right? We'd added 20 to this one, to the 0.952, so the next one is 20.952. And those are my first three positive solutions. Okay, how are we on the calculator? Yes? Yes. Then so if that turned out wrong, then either we calculated the period wrong, or so we input this equation wrong. We would just have to double check to see what went wrong, because it should be exact. Okay? All right, how are we on the calculator? Are we okay on this part? All right, great. So let's go to our second topic for today, which is writing equations from graphs. That's on our second slide. Okay, yes, I got a little crazy with the border. I love this border. I thought, oh my gosh, they're going to hate this border, but I like it, so we're just going to just humor me, right? Just humor me. So we know we've been dealing with graphing for several days now. We know how to graph. And as always in math, once we learn how to do something one way, we go backwards, right? So we're actually going to look at the graph, and we're going to write equations from the graph. Now that's our task with this particular part of the lesson. So we'll take a look at this graph. We're going to write equations from it. So let's start. The first thing that we want to do is we want to figure out, you know, what A and B, you know, what all those things are. So if we look at this graph, the high point is at 3 and the low point is at -5. We know that exactly in the middle this is going to be the sinusoidal axis, right? Exactly in the middle. So we say, okay, so 3 to -5, that's a total of 8, right? It's an 8 distance. So 4, right? We half it is going to be in the middle. So if I go up here 4 or down here 4, that's going to take me to a -1, right? Our sinusoidal axis is going to be at a -1. So I'm just going to kind of sketch it in. So this is at -1. We know that the distance from the sinusoidal axis to the maximum or the sinusoidal axis to the minimum is our A value. All right, so our A, I'm just going to start listing things. A is 4. Okay, great. We need to know B. In order to know B, we need to know the period. We're going to have to read the period from off of the graph. Now, I'm going to read this graph as a sine graph right now. We could read it anyway, but I'm going to read it as a sine just because it starts like the regular sine graph, doesn't it? It starts at its sinusoidal axis, and it goes up, and it ends right here. I can tell from that that my period is pi. So the period is pi. We know our formula for sine is the period equals 2 pi over b. Right? That's our formula for sine and cosine when we're in radians. So if I know that the period is pi, and I know the formula for the period, I can just set these equal to each other, right? And I find my b. So let's see. So we have pi equals 2 pi over b. And then I solve for b, and I get b equals 2. So you could cross multiply. I mean, there's a lot of things you could do to solve for b. But we have that b is 2. C is going to depend, it's a phase shift, it's going to depend on which equation we write, so let's just not mess with C. And let's find D. So if you recall, D is the shift, the vertical shift. Have I shifted up or down? Where have I gone? We look at our sinusoidal axis and we see that it was shifted down 1. So D is going to be a -1. Now I've pretty much collected all the information that I need to start. Now the great thing about this is we have 3 of the 4 values. The only thing we need on all of these equations is just the phase shift. I mean, you could even do a template. You could just write everything out and just leave the phase shift blank. So let's do that. So we have y equals, we know our amplitude was 4, so 4 sine, our b was 2, x I don't know, and then -1. I'm just going to leave that blank. So on a quiz or a test, you could get most of the credit, right? If you just write that out, we just need our phase shift. So looking at just a plain sine, the regular sine does not have a phase shift, right? Because sine typically does start at the y-axis. So this would be a -0, or I mean, you didn't have to put it at all. I'm just going to leave it like that. Just leave the phase shift like that. So that is our sine equation. Okay, let's write our cosine equation. So the great thing again is I know a is 4. It's cosine. I know that's a 2. X, I don't know, -1. See, I just fill that. All of it, the template's there. I just need to know the phase shift. So we look back at the graph. Now, I need to talk to you about phase shifts on these types of things. So this is kind of important. I hope you're listening, because so I've taught TAG students for a very long time, and I realize that if I don't give parameters, I get some crazy phase shifts, like 1,000 away or something. Okay, and I really don't want to do like 25 keys, right? So what my requirement is the phase shift that you use needs to be the one that is closest to the y-axis. I mean, that's pretty straightforward. We want to use the phase shift that's closest to the y-axis. Okay, so you need to be sure you make note of that, because if you use a different one, I'm going to take off points. You need to use the one closest to the y-axis. So let's look at this. We want cosine. We know cosine starts at the top. I could use this one, or I could use this one, or I could use the one way over here, or an infinite number. Which one am I going to choose? I'm going to choose the one that is closest to the y-axis, right? This phase shift is closer to the y-axis than this one. So see, so where should this be? It should be here. But it's been moved right pi over 4. Or it's been moved right 5 pi over 4. Or it's been moved left, whatever that is over there. Right, but what am I going to choose? I'm going to choose the closest one. So I'm going to say it's been moved right pi over 4, which means it's minus pi over 4. I want to make sure we all understand that. So where is it supposed to be? It's supposed to be on the y-axis. Where is it? It's right of the y-axis. So that means that's a negative one, right? That's our shifts. Okay, so here we go. Now let's work on a negative sine equation. So y equals -4 sine 2x for something -1. Doesn't that just feel good? We have like most of the answer written out, right? That's great. So now let's think about negative sine. So if you recall, negative sine goes like this, right? It starts at the origin and goes down. That's the negative sine. So let's see. So we need to start here. Okay, right there, and go down. There's one. And there's actually one equally spaced on the other side too. You could use either one, but since I already see this one, I'm going to use this one, because that would be a negative sine. Right? It would start here and it would go down. So my phase shift is right pi over 2 or minus pi over 2. Okay. And the last one on this one is a negative cosine. So y equals -4 cosine 2x -1. So fantastic. All right, so now let's think about what a negative cosine looks like. Let's go up here. So cosine usually starts up, right? So the negative cosine is going to be like this. It's going to look like that. So that's what we're looking for. That's the shape we're looking for. We need to start at a low and then go up. So let's see, we have a low here and we have a low here. So I could use this one or this one. Which one am I going to use? this first one because it's closest to the y-axis, right? That's what our goal is to be closest to the y-axis. So let's see. This really should be at the y-axis. So what happened to it? It was moved left pi over 4. Right? It was moved left pi over 4. So this is a plus pi over 4. And there is my negative cosine equation. Yes?
Just so happened on this problem that cosine and negative cosine have like
Yes, it has. No, it's by chance that these are opposites, and it has to do with the period. Yeah, if our period was different, then it would be different. Yeah. All right, so there is that one. Now let's do a tangent one, just because tangent is just a little weird, right? It's not shifted normal. Like its little belly is at the, okay, it's not, I think of it as little belly, right? Its little belly is at the y-axis, so the middle of it's being shifted. Instead of everything else is the ends are being shifted. So here it says write as a tangent equation and a cotangent equation, but on your daily work it asks you for a positive, negative each. So we're going to do a positive, negative of each. We're going to do 4. So let's gather information. We need A. Now for tangent, we know there is no amplitude. A manifests itself in the distance between the middle point and the upper point, or the middle point and the lower point. And so this distance, 5 to 8 or 5 to 2, is a 3. Right, so our amplitude is 3. But again, it's not amplitude. Our A value is 3. All right, so let's look at the period. So the nice thing about cotangent and tangent is where the period is really distinct. It's between the asymptotes. So I have one asymptote at a -1 and another one at an 11. So I know the period is 12. So the period is 12. Let's look at what our normal period looks like. See, these do not have degree signs on them. So we are in radians. See these little numbers? No degree signs. We're in radians. So let's see. Our normal period for tangent is pi over b, right? P equals pi over b. That's the formula for us. And so our period is 12. So 12 equals pi over b. So b is going to be 12, pi over 12. B is pi over 12. Okay, are we okay? C value we're not going to mess with, right, because it's going to change depending on what we're doing. Let's work on the D value. The D value is the shift, the vertical shift, up or down. We know this middle part is supposed to be at the origin. So what, it's been shifted up 5. So our D is 5. Is everybody okay so far? Okay. So now let's write a tangent equation. So we have y equals 3 tangent pi over 12 x with something plus 5. Okay, we have the template filled out. We just need the phase shift. So let's think about tangent and its tangent's phase shift. It's the middle part that's been shifted from the y-axis, right? The little belly. So I have to decide, is this one closer to the y-axis or is this one closer to the y-axis? I think we agree this one is closer to the y-axis, right? So this is the phase shift I'm going to use. It was shifted right 5, right? So it will be -5. How is that? Okay, so now we're writing a negative tangent. Now this is actually kind of easy. Let's think about this for a second. You're thinking, oh my gosh, a negative tangent? That's crazy. Well, I know that if I put a negative out here, it's going to look like a cotangent graph, isn't it? It's going to go like this. So not only do I need to put a negative here, that kind of a shift, a transformation, I also need to put a negative here with the negative pi over 12. So if I double negative it, it's going to look exactly the same. It's going to undo itself. So it's going to be -3 tangent negative pi over 12 times x minus 5 plus 5. Okay, and you can put that in the calculator and graph it if you want to. I did just because I thought it was super fun. They're the same thing. Okay, so writing a negative tangent graph is way easier than writing like a negative sine or cosine graph. It's way, just put the two negatives in, you're done. Right, everything else is the same. So now let's work on cotangent. Y equals 3 cotangent pi over 12 x with something plus 5. So now let's think about our transformations for cotangent. Remember, cotangent's its asymptote starts at the y-axis, right? So I could choose this as my transformation, or I can choose this as my transformation. I think that's really obvious which one's closer to the y-axis, right? It's this one. So I need to choose this one. So this is supposed to be on the y-axis, but it's been moved left 1. So left 1 would be plus 1. Right? That's what my phase shift would be. Okay? And then to write the negative cotangent, okay, or actually, sorry, this should be negative. Because why? Let's talk about why. That 3 should be negative because if I left it positive, it would be shifted the proper way. Everything would be good, but instead of going like this, it would go like this. We don't want that, do we? Cotangent goes like this. In order to change him so that he looks like tangent, we have to put a negative there. Right? That will switch him. So I'm going to pause here for a second. Are we okay with that? That will cause him to flip upside down and look like tangent. So now if we're going to write a positive cotangent graph, what do you think we're going to have to do? Yeah, we're going to have to take the negative off here and put the negative on there, and then we have a positive one. So these are easy to write. 3 cotangent negative pi over 2, excuse me, pi over 12, x plus 1 plus 5. And then we got it. How are we doing? We okay? All right.